All right, 6.3, we're talking about systems of linear inequalities. Okay, so we did systems of equations at the beginning of the unit. Now we're doing systems of inequalities, which is just two or more linear equalities graphed together. Okay, now when we did just one inequality, the solution was any ordered pair that made the statement true. But in a system, we're looking for an ordered pair that makes both inequalities true. There's still going to be multiple solutions, but it has to be true for both inequalities. Okay, so we'll do one to start. Okay, y is greater than negative x minus 1. So my first y-intercept is negative 1. The slope here for negative x is going to be negative 1 over 1. So I'm going to go down 1 over 1, down 1 over 1. Okay, I'm just going to do a couple and then do my best to draw a straight line on the computer. That was awful. Let me try again. Okay, let's see. All right. And then y is greater than that. Whoops, that needs to be a dotted line because it's just greater than, no or equal to. Okay. And then because it's greater than, I'm going to shade above the line. Okay. Then my second inequality is y is less than x minus 5. So I'm going to go to negative 5, put my y-intercept, and then my slope is going to be 1 over 1. So up 1 over 1, like that. Okay. This is also going to be a dotted line. All right, remember when we did inequations or systems of equations, we were looking for the one point where the two lines cross. But because now we're talking about inequalities, we're looking for where does the shading overlap. So less than x minus 5 means everything below the line. Okay, so this area right here where I have both blue and green shaded in, that is my solution area, okay, where both of them are shaded in. I have different colors, and when we're doing work in class, if you want to use colored pencils, you can, but they're hard to erase, so I would do it in pencil first. Or you can just take your pencil and like fill it in darker. Like if I do my normal shading like this, when I get to the overlap, I can just fill it in darker, make it very clear where the things overlap. Okay, so I want you to pause here and try number 3. You're going to have to get this first equation in slope-intercept form first before you can graph it. All right, so your graph should look something like this. When I solved the first equation for y, I got y is greater than or equal to 1/4 x minus 6. So that is the blue line that I shaded above. And then this one is already in slope-intercept form. So that is the green line, and because it's less than or equal to, I shaded below. And then I filled in with yellow extra where both the blue and the green are shaded in. All right, we're going to skip ahead a page to where it says more with linear inequalities. So this is the other thing that we have to do, which is be able to look at a graph and decide what ordered pair is a solution. So the first thing I'm going to do is I'm going to graph this inequality, and to do that I need to get y by itself. I'm right up here so I have some more room. So negative 5y is greater than or equal to negative 3x plus 10. And then I'm going to divide everything by negative 5. So now I have y is less than or equal to, flip my inequality, positive 3/5 x minus 2. Okay, so I'm going to graph that. All right, I'm going to count up 1, 2, 3 over 1, 2, 3, 4, 5. And then I'm not going to have room, so I'm going to reverse, and I'm going to go down 3 and then left 5. All right, so it should look something like that. It is or equal to, so that makes it a solid line. And then less than means underneath the graph. Okay, and so now, which one of these is a solution? Well, the answer is the one that's in the shaded area. So let's graph each of these points. So 1, 4 would be right there. That is not in the shaded in area, so that is not a solution. 6, negative 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. That is in the shaded area, so that would be a solution. All right, we're going to do the rest of the points just because. Negative 5, negative 2, so negative 1, 2, 3, 4, 5, negative 2. That is not in my shaded in area, so that is not a solution. And then 2, 0 is right there, and that again is not in my shaded in area. Okay, we can do the exact same thing with systems of inequalities. All right, so I'm going to scroll down, let's see, to number 6. All right. I want you to pause and graph these. Okay, just graph them and then we'll go through the solution part together. All right, so your graph should look something like this. Okay, I got y is less than or equal to negative 1/2 x plus 3. That's the blue line. And then y is greater than 3x minus 2. That is the green line. Okay, and so now I'm going to look and find these ordered pairs. So negative 3, 2, negative 1, 2, 3. 1, 2 would be right here. That is in my solution area, so that would be the solution. But like I said, we're going to check all of them. Okay, so 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That is outside my area. Okay. So that one is a no-go. Negative 1, negative 7. So negative 1, 1, 2, 3, 4, 5, 6, 7. That's in my blue area, but not my green, so that is not a solution. And then the last one we're going to check is 5, negative 2. So 1, 2, 3, 4, 5, negative 2. Again, in my blue area, but not in the green as well, so not a solution. All right, and that's it for systems of inequalities.